Mrs. A did not think the joke was very funny this time at all. But I think it's hilarious, so I'm going to keep putting them in there. Now, we are once again going to be working on dividing multi-digit numbers, but this time we're going to use a different algorithm called partial quotients. Now, this gives us the same answers that the other algorithm does, but it's really effective for when we are dividing by a number with more than one digit or a larger divisor. So the key before we start partial quotients is to remember that division is just repeated subtraction. If you don't remember that as repeated subtraction, the process doesn't really make any sense. But if you do remember that, it actually isn't too bad at all. So instead of having to only find the largest multiple that's as close to 30, in this case we can totally throw that out the window and pick any number that we want. For example, I like to do a multiples of 10 right away. So I know that 12 times 10 is 120. And I can just do that subtraction here right away. It actually is not anything trickier than that. And now I just subtract whatever I have left over from this process. Now I do the subtraction just like I've always done before, which gives me 180 left over. Now, once again, I can pick any number out of thin air. I love picking multiples of 10. So once again, I do 12 times 10, which gives me 120. And I subtract once more. When I do 180 times 120, that means I have 60 left over. Now, if you remember from the other video, we know that 12 times 5 is equal to 60, but what if I didn't know that? What if I was like, what about 3? What's 12 times 3? Okay, so then I do 12 times 3, that gives me 36. And once again, I just subtract, I get 24 left over, and at this point, I know that 12 times 2 is 24, and I have a remainder of 0. Now the question becomes, what do I do with all of these leftover multiples? Well, I just simply add them all together. I know that we subtracted 10 and 10 and 3 and 3. So we subtracted a total of 25. Therefore, 12 times 25 is equal to 300. And the benefit of this right here is that I don't have to pick the exact number or the closest multiple as I work through. I can just simply guess as I go. I don't have to think of multiples on the side. I can just think of them as I go into the problem. So for certain types of problems, especially problems like this, partial quotients can be incredibly helpful. So I like to draw the line down the side just to kind of keep me organized. I stole that one from Mrs. A. And now I just simply have to think of any number that I want here. Now, I like to start with multiples of 10, but you don't have to. But I know that if I do 13 times 100, I will get 1,300. Now I moved my 100 too far down, so let me move that back up here. So that's usually where I start. I like to start with 100. So now I subtract, just like I've always done. And let's see how much we have left over here. I have 1,742. Well, I know I can subtract 100 again, so that's what I'm going to do. I'm going to change color here a little bit just to kind of help us keep track. So there we go. I subtracted another 113s, and I have 442 left over. Now, this is where I can get a little bit trickier. You kind of just have to guess. Now, I'm going to try, I know that 100, or 10, sorry, would be 130. So let's do 20. That seems like a pretty safe number. 13 times 20, that would be 260. So I subtract, whoops. And that means I have 182 left over. I'm going to subtract 10 again. So that means I have 52 left over, and I know at this point that 4 times 13 is 52. So that means I have 4, and then I have nothing left over after that. Therefore, I simply add up all of the subtractions that I did. So 100 plus 100 is 200. That'd be 230, and that's 234, which means 13 times 234 should be equal to 3,042. And let me get out my calculator here just to double check, make sure I didn't throw this one completely off. 13 times 234 is 3,042. We are dead on. All right, so we have two left here, both of which are really good candidates for the partial products method. So for the first one, I have 22 times 22 is dividing into 1,430. So I draw my line down the outside just again to help me stay organized. And then from here, I want to figure out how many times I can subtract 22 from our number. Okay, so I'm going to start with, I know that 100 is too big. I'm going to start with, let's go 30. Okay, because I know 3 times 22 is 66. So 22 times 30 would be 660. So let's do that. Okay, so from here, and this is by far my favorite part of this process, because even I as a math teacher don't magically have these answers all memorized. So it's actually very helpful to kind of just guess as we go. So from here, I'm going to subtract 660 again, which gives me 110 left over. Now this is where it gets a little bit trickier. Let's look at 22 times 5. So that gives us an extra. And look at that, we got really lucky with that one. So it actually has no remainder as well. Therefore, we subtracted 30, 60, 65. Therefore, 22 times 65 is equal to 1,430. So we have one problem left. Okay, and this one is kind of tricky. Okay, when we have a divisor of 31, normally that means we have a pretty difficult problem ahead of us. But with partial quotients, it's actually not that bad at all. I'm going to do, let's do 20. 20 seems like a pretty safe bet. If I do 31 times 20, it would give me 620. So I have 341 left over. Okay, so we can't do 20 again, but we definitely could do 10. So let's do 31 times 10, which gives me 310. And I subtract once again. And that means I have 31 left over. That's pretty nice. So I just do 31 times 3. Once again, I have a remainder of 0. So this gets me 31 as my answer. So 31 times 31 is equal to 961 as my answer. So that's partial quotients. Works really well when you are dividing by larger numbers. It gives you the same type of answer that regular division does, but you don't have to get as close to your target number as possible, so you can really just kind of guess and check your way down. It can be a very effective tool depending on where you are in terms of understanding. As always, if you have any questions, make sure you let me know.